Hello, everyone, and welcome to Dycem's Improve Your Contamination Control Strategy, brought to you by Dr. Tim Sandle. We have so many exciting topics to go over today for you, so we're going to hop right into the session. Our speakers are Dr. Tim Sandle from Bioproducts Laboratory. Dr. Tim Sandle is a pharmaceutical microbiologist, science writer, and journalist. He's a chartered biologist and holds a first-class honors degree in applied biology, a master's degree in education, and a doctorate from Keele University. He has over 25 years of experience in microbiology research, quality assurance, biopharmaceutical processing, and is a contamination control expert in the field. I am Sarah Finnerty, and I'm the marketing manager here at Dycem. Just to go over a few housekeeping items to get us started, please submit your questions throughout the webinar. There's no need to wait to the end, and then we'll cover everything as we wrap up. Please ask Dr. Sandle any questions you might have about your own contamination control strategy or anything that you'd like to clarify. We also have great related content for this webinar that will be in this link. It'll also appear in the bottom right of your screen. If you have any issues with the platform, please go to the help icon on your screen and you'll be able to resolve it from there. And with that, Dr. Sandle, I'm going to kick it off to you.
Okay, thank you very much. And it's a great pleasure to be with you all wherever you are around the world. So this is a webinar that's kind of going to be split into two parts. So in the first part, we'll be looking at 9 essential areas that kind of fit in with the whole contamination control strategy ethos. So there were a number of areas I could have selected, but I've picked on these 9 because I think they're a combination of realistic kind of risk-based things and things that you can go away and do in a practical sense. And then in order to kind of pull these disparate strands together, I wanted to then to present on a case study, which was some work that I did with Dycem, which is looking at the effectiveness of special flooring to reduce fungal contamination from footwear. So we've got a quite a broad range of different topics to look at. Okay, so before we jump in with the main part of the presentation, what we've got is a series of polls at different points in the webinar. So just in order to kick off, if I can ask the question whether or not you have a contamination control strategy in place already, if you could just click yes or no, that'd be really useful for us. So I'll just give you a few seconds to click away. Okay, right. So let's go on, and hopefully we can see the answers. How about that? Fantastic. So of the many of you listening, 72, almost 73% have a contamination control strategy in place, and 27% do not. So hopefully for those who do, there'll be some things that you can pick up and help to reinforce your contamination control strategy. And for those of you yet to develop one, hopefully there are some things that you can begin to pick up and start to run with. Okay, so first of all, why do we want to have a contamination control strategy? Well, if we have to follow EU GMP, then it is a regulatory requirement. And for those who don't necessarily come under EU GMP, but come under different regulatory bodies like FDA, then the FDA was a shadow organization during the creation of Annex 1, and there's a good chance that FDA aseptic practices guidance, when it is updated, will also have some similar requirement. So this contamination control strategy is in place to sort of highlight the need to help us define and determine the critical control points within our manufacturing processes, and also to help define and develop and understand the effectiveness of our controls. So there are some keywords, and I've put a quote from Annex 1 at the bottom on the slide, and if you read that and then the kind of broader area of the annex, and there are some keywords I think that are worth emphasizing when we think about contamination control. And these are that it should be based on science, be scientific, that it's risk-based, that it acknowledges the risks and proposes appropriate corrective and preventative actions, that it's robust enough to last for the applicable product life cycle, and also that it's something that's subject to regular review. So it's a living, breathing entity. In terms of the types of things that the contamination control strategy should include, I mean, foremost, it needs to be something that is site-wide, and there's a word that I'll probably end up using several times, which is holistic. And it needs to cover things like the design of the plant and processes, extending out to premises and equipment. It needs to include people. It should cover the utilities. It should cover raw material controls, including in-process controls. It should include vendor approval, and in particular, the approval of vendors that are supplying sterilized components and equipment to the site, things like single-use disposable technologies. It should cover the management of outsourced activities, particularly in terms of quality control testing and also with sterilization. It should include process validation, the validation of sterilization processes, preventative maintenance, our monitoring systems, and also the way we handle data in terms of trend analysis, root cause determination, and so on. A well-designed contamination control strategy will also consider the different sources of contamination, and this will allow us to build in the appropriate measures to assess hazards and to ensure that we appropriately evaluate the risks these hazards present to our products and to our processes. So we would need to include, for example, an assessment of incoming raw materials, and here we would need to know we're buying them from a reputable vendor, that they're of appropriate pharmaceutical grade, and we would have to determine certain limits for bioburden, whether we had a concern about objectionable microorganisms, and also potentially endotoxin. With things like containers and packaging, then we might have concerns about the leaching of impurities when we get a product coming into contact. With machinery, we may have a concern, for example, with parts that we cannot clean effectively, or perhaps which produce high levels of particles. With vessels, this could be a combination of how well a vessel mixes and our desire to create a homogeneous solution, and also with areas, again, like cleaning validation, and also concerns with wet equipment and that ability to produce contamination. And then we can also extend this to consider things like design of the clean room, particularly with air dispersion. So we need to have an understanding of what the likelihood of contamination being blown towards a product, particularly where we've got open processing, with the training of operators, so the mindset of behavioural issues and gowning controls, clean rooms, which we've touched upon, but In particular, one of the vulnerabilities is areas adjacent to clean rooms. So we'll have a look at that in a moment. And also with water, it gives us a dual problem sometimes because it's a vector, a way of spreading contamination, but it's also a growth source, a growth requirement for a range of microorganisms. But once we've established a contamination control strategy, another important dimension is with the governance of the contamination control system. So we need to carry out regular and periodic checks to verify that our contamination control system is working properly. So we can draw inputs from other parts of the quality management system. So we may get indications of how strong our controls are from deviations, from CAPAs, from change management, from microbial data excursions. And we will need to take all of that and to ensure that we can drive continuous improvement and seek to further reduce contamination issues as they arise. And we can only really seek to achieve this through the use of cross-functional teams and having regular reviews so that we can respond robustly to changes to our approaches. Okay, so that's kind of a way of introduction, trying to put the contamination control strategy into context. But let's now have a look at, before we do that, I was going to move on to my 9 areas, but let's just have another poll question. So if you have a look at the question on the screen, so this is asking what are our biggest sources of contamination? So do you think it's people, air, the facility, down at floor level, or some other fact on the slide? So if you just take a couple of minutes to click, which is your strongest feeling for the main source of contamination. Okay, brilliant. So let's click on and see what the answers are. Wow, so that's really good. So people as the biggest source of contamination, and I think that's borne out by a lot of studies and findings where some of the highest recoveries, say environmental monitoring, are those organisms that have an association with the human microbiota, particularly in relation to the human skin microbiome. So yeah, great answer there. Okay, now our 9 focal points, our 9 tips for the contamination control strategy. Okay, so the first thing I've selected is this concept of zonation. So another word for that is holistic. So in the context of the contamination control strategy, this means that, you know, while we will pick individual areas to have a look at, so on the slide there we have a controlled not classified area, or sometimes people prefer clean not classified, but CNC, and items coming from a warehouse. We might well take those in, take them through airlock, take them to grade C, then to grade C, to grade B, and maybe reaching our aseptic core. So we do need appropriate flows, but we need to bear in mind that even though we might look at individual areas, that what happens in one area can actually affect another area. So we can get transference of contamination. And again, studies have shown, say, for example, that build-up of contamination in grade C eventually has an interrelationship with grade B, and that's because of the different access points that we would potentially enter by. So understanding that and accepting that is an ever-present reality is a very important thing for understanding the contamination control concept. And that's perhaps better illustrated through this idea of the contamination control cascade. What we should expect is a reduction in microbial and particulate contamination as we move through different grades of clean room. So on this particular slide here, we have the EU GMP DCBA grades, and we've also got their ISO class 14644 equivalents as well. And depending on the sample type, we're going to have different levels of, or different maximal levels of bioburden that we'd want to see. So if you look at EU GMP grade D, for example, what we have at the bottom of the boxes where we've got the letters CFU are the maximal limits for the active volumetric air sampler. So grade D, 200, grade C, 100, B, 10, and grade A, we're into expecting zero recovery. So you can see there that reduction in bioburden. But we need to be particularly mindful, as I was saying, in the areas where we've got interconnection between these clean rooms of different grades. So we will have weaker points at intersections, so things like airlocks, be they airlocks for materials, changing rooms, which are effectively airlocks for people, and things like transfer hatches and the like. So there are concerns, and we need to focus on those as the particular points of our kind of zonation concept. Okay, so that's tip number 1. Tip number 2 is this kind of idea of having contamination control ambassadors. So having ambassadors, people to kind of live, feel, breathe, and discuss contamination control, advocates, if you like, is very important, because our employees are really important, and they can help us to represent these ideas and help us to promote the contamination control concept positively, both internally and externally. So they can help do the interconnections, help cascade information, contextualize the information, and also lead by good examples. So things like promoting the importance of contamination control, helping us build the quality culture, focusing on things like hygiene, effective gowning, undertaking cleaning and disinfection according to requirements in a standardized way. Another thing, is encouraging critical thinking, fitting into this kind of wider concept of a quality culture. So even just reinforcing things like think before you act are just important things that these kind of behaviours can help us to encourage. Okay, so let's move on to the third area. And our third area is to do with training and the control of people. So effective training, laying out, especially for people who've not worked in the pharmaceutical sector before, what is a clean room? Why is a clean room different to a different environment? And helping them through learning some of the different ways of working, because these are very kind of alien concepts if someone's worked in a very different industry. So the number of times somebody would need to practice gowning going into an aseptic area for the first time is probably quite high. I mean, I would say at least 10 times just to get this right so that the gown doesn't touch the floor, for example. And there's a number of things that really need careful attention. So with hygiene, that's not only a discussion around personal hygiene, but also with the frequency of glove disinfection when the person's in the clean room, and hand washing going through the changing process. And then going into the clean room, this idea of slow, deliberate movements, and showing the difference between walking quickly and the number of particles that are generated, and with walking slowly. Because the typical clean room suit will retain around 90% of the contamination likely to be shed from the operator. If we're in an aseptic area, we'll probably be wearing double suit, but even then there's always going to be an element of particulate release, and the faster the movement, the greater the quantity of particles that are released. An understanding of aseptic technique as well, and various practices with that, using things like broth cultures as well, it can be really important. Understanding the consequences of what might happen should a product become contaminated, so the potential loss of sterility, and also an understanding of just sort of basic microbiology. And it's one of those things that Annex 1 calls out. It says that it's very useful if people working in clean rooms have a basic understanding of both microbiology and also engineering to a degree. So that they're important concepts. But training should be continuous. It shouldn't be anything that ever stands still. It should be a continuous cycle of reinforced learning. So varying things like GMP refresher training, or good microbiological control practices, or sterility assurance, whatever term we wish to give it, doing something slightly different each year is really important. And for those people who are tasked with running aseptic processing lines, then there may need to be an extra layer of training, particularly for those who are required to perform interventions into the aseptic core as well, and including things like airflow visualization studies or smoke patterns, and showing operators what happens when disruption occurs, or using things like UV fluorescent fluids, and then using UV lights to show what happens if you miss certain areas of cleaning. All of those sorts of things can be very effective. Okay, so the third area that I've selected, the third tip, is with rapid methods, particularly rapid microbiological methods, sometimes called alternative microbiological methods. And Annex 1 in particular says that there are opportunities to adopt some rapid methods and to use these to help enhance the contamination control strategy. So rapid methods for microbial detection are often things that are sensitive, precise, and produce the result faster. And we can kind of group some of the available technologies into qualitative methods. So these are about the presence or absence. So we can use that to, say, use DNA probes to look for the presence or absence of an objectionable microorganism in a given sample. We have quantitative methods that will give us either a direct measurement of microorganisms or some indicator that there might be microorganisms present. So spectrophotometric or biofluorescent particle counters, for example, can differentiate between viable and non-viable particulates based on metabolic components of microorganisms that might autofluoresce. Now, we don't get direct CFU, we get a potential that there are microorganisms present. And then we have other rapid methods, such as those that are helping us with microbial identification, so things like Morditoff, for example. But there are an array of different rapid methods out there. There's no universal one that's going to suit all of our needs. And some of these technologies are quite novel, so we always need to be careful when we are selecting the appropriate method. So it's very important to sort of stand back and say, okay, this technology is really exciting, but what do I actually want from this rapid method? So we need to consider the issue of time. But time is can be looked at from different angles. So a rapid method might give us a result far more quickly, but the technology might involve the laboratory analyst spending longer preparing a sample. So if they have to, say, fluorescently label a sample, that step might take longer than a conventional, say, membrane filtration test. So we need to weigh up time to prepare the test, time to conduct the tests, whether or not we would need to do more or fewer complementary tests, what the time is spent on data analysis and data reporting, and also what our sample throughput is as well. So we may get the result faster, but we might be able to put fewer samples through. So that's something we have to consider. Another thing with the rapid methods is, what advantages we wish to garner from accuracy. So rapid methods can help us with error reduction, such as plate counting. So there are technologies that will count microcolonies and count so earlier and also count far more accurately. And if a human has to count hundreds of plates, then after a period of time, fatigue might well settle in. Or perhaps someone wasn't trained fantastically in the first place and has trouble differentiating between a colony and some other marking. We also have another consideration with the rapid methods, and that's the concept of whether the organism can be cultured as well. So before we come on to that, let's have another poll question. So based on some of the descriptions of rapid methods that I've said, where you work at the moment, do you have a rapid method or something you might class as a rapid method, or is this still technology that you might be weighing up or wishing you have the budget to purchase? So it's a couple of seconds for that one. Okay, let's see what the answers are. So the vast majority don't yet have rapid methods. So the inference I'm taking from that is that you're very reliant upon culture methods, standard agar plates, and so on. So which is really useful. So one of the things where rapid methods can give us more information is with this concept of culturability. So there are organisms that are sometimes called viable but non-culturable, sometimes called active but non-culturable. So these are either organisms for which no culture medium has yet been created that they can grow on, but these are often the types of organisms that we won't necessarily find in our clean room environment, because as most people rightly said, that the people are the biggest contamination source, and most of the organisms we're going to be concerned about are those that are going to be shed from human skin. However, clean room environments are quite harsh. Organisms are going to be subject to UV light, to very dry conditions. We're going to be using disinfectants, and there's going to be a small population that could survive, and these organisms might retain metabolic activity, but they won't necessarily grow on conventional culture media under those particular conditions that we're trying to resuscitate them. So you could argue from one point of view that we still stand a chance of picking up the majority of contaminants with conventional methods, and hopefully a lot of these are relatively healthy, but there's going to be a degree that are non-recoverable, and that distinction probably becomes more important as we move through the clean room cascade and we get closer to grade A. So probably the important message there is that when we're looking at contamination control strategies, we can't have an absolute reliance upon environmental monitoring because organisms might be present. It's just that we may not be able to detect them. So we should always look at control first and monitoring second. Okay, so the fourth tip is, might seem a strange one, but it's preventative maintenance. And this is how we maintain our facilities and how we carry these maintenance tasks out with appropriate procedures and controls. Because we need to understand, what happens within our clean rooms when engineers have to come in and open up panels which are not normally opened into the clean room, which will not be subject to the standard cleaning regime. And these can be reservoirs of spore-forming organisms, for example. We need to understand things that, like, if we send equipment away for repair, how do we decontaminate that equipment when it goes back into our facility? And we also, as part of continuous improvement, may simply want to try and minimize the number of times that a piece of equipment might break down, so we can determine how often an engineer actually even needs to go into the clean room in the first place. But it's important that those who are tasked with contamination control understand how maintenance happens and are involved in the risk assessment in relation to those works. And another area that has impact is going into facility shutdowns and coming out, and the level of cleaning and disinfection that is also required. Another consideration is with aging facilities as well. In many parts of the world, the pharmaceutical facilities that we occupy were built 20 years ago, 30 years ago, maybe even older. And aging facilities require an increased level of audit and inspection to look for damage. We can start getting damage to fabric. That can start affecting our pressure cascades. It can produce alternative routes of contamination ingress. And it might be that certain older facilities might need higher levels of environmental monitoring, for example. Okay, the fifth tip. So this one I've headed environmental feng shui. But by this one, I'm really talking about risk-based decision making and the application of quality risk management into our facility design and trying to establish appropriate levels of control. So a few minutes ago I said that control is the most important thing, and it is, but we also need to decide where the most appropriate points are to monitor and the types of monitoring that we should be introducing. So one useful risk assessment tool for that purpose is HACCP. So HACCP is one of the risk tools listed in ICH Q9, and it was one of the tools that the pharmaceutical world has adopted from the food sector. So HACCP is Hazard Analysis Critical Control Points, and this involves using process flow approaches to identify potential sources of contamination and routes of transfer, particularly areas where contamination could be directed towards the product or product contact surfaces. And this allows us to kind of map routes, understand where people go, where equipment goes, and then to question whether our current controls are indeed appropriate. So we can produce kind of simplified maps like this, for example. The map on the left-hand side is looking at the routes that people are taking, both coming in and out of a particular clean room. And we could also do similar things for waste in, waste out, product in, product out, and so on. But with our understanding of that, we can then look to add a little bit more meaning to our environmental monitoring locations. So we can work out where do we want to do contact plates of, say, a floor to check on the level of hygiene. Well, it might be the area where most people go. Where are people in relation to products? That might be the area to do air monitoring. It's just this kind of approach and some of the ideas that we can start to use, and then we can also apply similar thinking to start to look at filling machines as well. So, and even within the filling machine, we can also think about the concept of zonation as well. So there's going to be different parts of the machine that present different risk factors. So our point of fill is arguably our biggest risk factor. And then we can also consider where our most appropriate monitoring locations are and where we want to bias and concentrate our monitoring. So again, in this simplified example, we've got a greater amount of monitoring around where we're actually dispensing product into open vials, and less monitoring where after a point we've actually stoppered our vials. So we can then start introducing a layer of different types of monitoring for different activities. So taking that diagram further, then we've got some examples of where we could place satchel plates, where we could place active volumetric air samplers, where we can consider continuous particle counting as examples, and these are all kind of geared towards the relative risk of contamination transfer into either into product or into our key product components like open vials. So it's just an example of the sort of risk structuring approach that we can use. Okay, so for the tip number 6, then we're looking at the use of Dycem mats and Dycem flooring, which hopefully you're familiar with to a degree, hence attending this webinar. But one of the common paths of contamination into a facility, but sometimes it is overlooked, is via what's going on at floor level. And the reason things at floor level are important is because within a clean room, contamination that's generated by us or by equipment, it goes into the air. It'll either, if we're lucky, remain in a turbulent state and be sucked out by room extracts, or more likely it will settle onto the floor, and then it can be easy to either disperse contamination up, or we can transfer contamination by walking through it or through the use of things like trolley cart wheels and so on. So we have 3 choices. We can either use standard flooring, standard vinyl flooring, and subject that to cleaning and disinfection and hope for the best, but that's kind of a one-off activity. After a period of time, that disinfectant activity wears off and the floor could become recontaminated. We can use the sticky mat, tacky mat approach. These often don't have a particularly large area. They're often left down for too long, so what was a nice kind of clean looking tacky mat soon becomes quite a dirty looking tacky mat. And when we change the tacky mat, then the activity of peeling off a layer can resuspend particles into the air, which can then land on people or on equipment. Another alternative, and the Dycem approach, is with the antimicrobial control mat made of polymeric materials. So there are a number of advantages of this type of flooring. So polymeric flooring has a strong electrostatic charge, and this can pull levels of particles from footwear, and that's to a level that is vastly superior to any standard flooring, and also superior to that of a tacky mat as well. And the flooring serves to trap the particles. In addition, the Dycem flooring contains an antimicrobial additive, and this is based on silver ion technology. And the way that silver ions work is that they latch onto bacterial cell walls, and they start to work on the outer cell structure and cause damage. And then once they penetrate and enter the bacterial cell, then they bind to nucleic material, and that stops protein synthesis, and then stops cell division, and then overall growth. So there are a lot of advantages here to minimizing contamination transfer, particularly again as we go through the clean room cascade. Okay, so here comes another poll question. So thinking about what goes on at the floor, what type of contamination control measures are you adopting at floor level? So are you doing nothing, just have your standard floor? Are you using sticky mats, tacky mats? Are you just wearing overshoes? Are you using Dycem mats, or do you have another strategy? So just a couple of seconds to consider that poll question. Okay, so let's see what the answers are. Okay, so a very, very small minority are not doing anything. And we have a roughly, an identically even split between the tacky mat, the sticky mat, and the Dycem flooring. We have a very high number of overshoe cover type approaches, and then we have some other strategies as well. So that's interesting. And when we come on to the second part in a few minutes, hopefully some of the advantages of the Dycem flooring will become apparent. Okay, so my seventh contamination control tip is around surprise audits. So we may have our controls defined, we might have wonderfully written procedures, but we need to periodically assess that people are doing things properly. And if we always announce that we're coming to audit, then everyone's on their best behavior, sometimes just turning up and spending a few minutes having a look at things can be very revealing. So in terms of sort of total quality speak, this is the idea of the Gemba going to the point where things are actually happening. So we can use quality assurance or microbiology personnel to do this, and we can sort of evaluate things like cleaning and disinfection practices. We can do reviews of fabric. We can make recommendations for new control measures. We can verify things are happening, or even go and look where we've had adverse results as well. But in terms of approaching this kind of visit, it's still useful to keep a kind of an approximate audit framework there. So we want to be systematic, we want to document, we want to assess, and we want to be objective. Okay, my eighth tip is kind of around putting the contamination control strategy together. So it's important to undertake gap analysis. So we might think we've got a great strategy, then we can have an inspection by a regulator and get pulled up for things that, oh no, we didn't realize that, and other factors. So even though it is a slog, reading EU GMP Annex 1 cover to cover is really important, and working your way through the 50 odd pages, addressing every single clause and thinking, do I have something in place that can answer that particular question? And to make it more manageable, you can kind of break it down into the different subcomponents of Annex 1. So you can look at facilities, processes, personnel, and so on. Breaking it down around those subsystems can be really useful. But we've also got the continuous improvement as well. So we need to be proactive, and this kind of touches on with that earlier tip about the contamination control ambassadors. We want people to report things and to say things that might not be ideal, and also to be willing to partake in continuous improvement exercises. There's also some that's going to be reactive elements as well. So we are sometimes going to get contamination. Here we want to have good root cause analysis and effective kappa setting, but what we want to do is learn from those. We want to look and trend our common deficiencies, our commonly set kappas, and then build those back into the contamination control strategy. And then we also want to have some key performance indicators as well, which help to signal how well our contamination control strategy is working. So it might be percentages above an action level, or it might be number of missed cleaning slots, or whatever's appropriate to the particular facility, and that will help to feed up into the governance structure that we mentioned earlier. And it's also important for us to use risk assessment and to use scientific thinking as well. So as we start to work through our flows of people and materials, we mentioned, and we start to look at our contamination gaps, and we start to identify hazards, we should initially consider each hazard for its relative severity and likelihood. But we also then need to say, okay, that might be the idealized state, but what's happening if it's person dependent, because that introduces a degree of variability. And then to consider, what are the consequences for product quality, and then are there any subparts to that, and then what's the appropriate level of control and the appropriate level of monitoring. Okay, so my final tip is about strategy and plan. So we've spoken about the contamination control strategy, and that is a important statement of principles, but we're bound to have gaps, we're bound to have continuous improvement things that we want to do, we're bound to get regular inputs of information from different parts of our feedback loop. So having a contamination control plan as well is also really important, because it helps drive those various things that we want to do, helps push us forward. And that concept of the feedback loop that I mentioned is kind of learning from all the signals from within the quality system, allowing us to periodically review and learn from our contamination control approach. So, what are our risk assessments saying? What changes are taking place? What are our deviations, signaling, and so on. But in order for that to happen effectively, then we also need people of the right attitude. I mentioned before about multidisciplinary teams, but it's important that people have an understanding of contamination, that they're drawing on their experiences, they have some level of technical knowledge. All that's important, and we also then are going to end up with an array of documents, and we need to work out how those documents interlink. So that kind of, again, governance level of planning is also really important. So those were the 9 tips. I'd just like to close out briefly with some work Dycem about showing the effectiveness of the flooring, and this is available also in more detail as a case study report and as an article, which I think could be shared with you, or we can share with you. So we have let's deal with the problem statement first of all. So we need to go into clean rooms. Often we'll go into clean rooms via airlocks and via changing rooms. And as I've already explained, a lot of contamination that is shed from people or produced from equipment stands a good chance of going onto the floor if it's not extracted from our clean room. And there is a problem that, every time we walk through, particularly when we transition from one grade of clean room to another, or from a corridor to a process room or through an airlock, we stand a very real chance of transferring contamination. And even if we're using captive shoes, then we've still got an element that we will be causing this kind of redispersal of contamination depending upon what's on the floor at any particular time. And there are published studies that show that polymeric flooring, such as the flooring made by Dycem, particularly with the antimicrobial silver ions, is highly effective. And a lot of this has been previously geared towards studies into bacterial counts. So one of the questions that I was discussing with Dycem is, well, okay, what about fungal counts? Because there's always going to be a degree of fungal contamination. What we are carrying on the human microbiome, there are elements of fungi. There's a lot of fungi associated with the as-built environment, Penicillium, Cladosporium, for example. And there are a number of fungi from the external environment that can be transferred into the clean room, Fusarium, Alternaria, also forms of Penicillium, for example. So we undertook a study, and the outcome of the study, which we're comparing Dycem flooring to vinyl flooring, was that the Dycem flooring was superior at removing fungi from footwear. So we ran a study where individual species of fungi, which I'll show you in a moment, were individually challenged onto standardized rubber-soled shoes. These shoes were previously unworn and had been decontaminated with 6% hydrogen peroxide. There was also one shoe set that was unspiked, and this served as a negative control. The target challenge to the sole of each shoe was between 10 and 100 colony-forming units of each fungus, and each shoe was repeated 3 times for each fungus. And the shoes were sampled, so we knew the challenge before, and then the shoes were sampled after walking across the Dycem flooring. And for walking across the Dycem flooring based on the manufacturer recommendations, each operator took 6 steps, equaling the 3 footsteps that is recommended for services like CleanZone. The fungal challenges were designed to be a broad range, so we're capturing different types of fungi. So we have Aspergillus brasiliensis, which is representative of filamentous fungus in the air. We have Botrytis, which is associated with vegetation, a Fusarium, which is another plant pathogen, Penicillium, more associated with the as-built environment, particularly water-damaged buildings, Mucor, which is an airborne fungus and also causes lots of problems in areas in Asia at the moment, and Candida albicans, which are the human-associated yeast. So what we found was that the Dycem flooring gave a mean reduction of all fungi down by 91%, and this was infinitely superior to vinyl flooring, which even with being treated with standard disinfection, only gave a reduction of 32%. So you can see the relative differences for the different fungi in comparison of the 2 surfaces. So the Dycem flooring was effective, and that was a combination of the physicochemical pull and the inclusion of the antimicrobial agent. So there was a clear level of reduction, and some really exciting and some really important outcomes there, which can add to the body of knowledge about Dycem flooring. And of course, with any study, there's future work to consider. So I want to do some more work with the length of time that the fungus is in contact with the shoe, with some different types of fungi, looking at different physicochemical interactions between the fungus and the shoe, different physical degradations of shoes, more variation between operators, more differences on pressure, and they could be interesting areas to explore in the future. But the overall thing was that you know, for building a contamination control strategy from the floor up, then the Dycem flooring in the context of the fungal work was really interesting and gave some measurable reductions in contamination. So that's the 9 tips and the overview of the study, and we move on to the Q&A.
Thank you so much for that, Dr. Sandle. It is always so informative to hear from someone else, especially an expert like yourself in the field, about how you think about these problems and then how we can handle them. I think we learn really well from other people's experience when it comes to contamination control. So with that, I think a lot of people have some questions. Our first question comes from Jenny. Who should own the contamination control strategy? Or as we just learned, the contamination control strategy and the contamination control plan?
That's an interesting question. I suppose without meaning to be like give this kind of fairly glib answer, but everybody really should have some involvement in the contamination control strategy. I mean, who owns it? I suppose ideally, if you've got like lots of resources, you'd appoint a contamination control manager. I guess, you know, the quality department has to administer it, but really it's a multi-stakeholder project. You know, you can't really do it without engineers, without production personnel, without microbiologists, without quality assurance, without validation. Everyone needs to come together, but like anything in any organization, you often need 1 or 2 people to help drive it.
That's awesome. Thank you. We have a few questions here about if your slides will be available after the presentation. And yes, they will be. They'll be available in the document repository. It should be towards the bottom right of your screen. If not, the slides will also be available after, as this is a recorded webinar. Our next question comes from Amit. There are some microbes that exhibit antimicrobial resistance when applying contamination control strategies, like antimicrobial control mats. How effective are these in such scenarios?
Okay, so with the Dycem flooring in particular, there's 2 things at play. So first of all, the physical interaction is something which no microorganisms have resistance towards. So the idea of prizing away contamination from the foot through the electrostatic pull is a physical measure. And then with silver ions, there is one of the antimicrobials out there which there is no real pattern of resistance that microorganisms have expressed themselves against. It similarly stands with most of the available disinfectants. It's only really with quaternary ammonium compounds that we start to see some potential resistance. But generally, for the types of antimicrobials we're using in pharma, it's very different to the antimicrobials we might take to help treat a disease in our bodies. So like the antibiotics, yes, there's clear resistance, but with a lot of the measures that we're still applying in pharma, there isn't really much indication of resistance.
That's a great answer. We have a similar question from Simon that says, do you recommend Dycem mats for particulate removal?
Yes. I mean, this is all, you know, very, very real. I'm not an employee of Dycem. I've used Dycem products for about 20 years, and I've undertaken a few studies. I've looked at bacterial removal, fungal removal, overall particle reduction, and I've also looked at what happens when tachymats are changed and the particle distribution into the atmosphere. And in every study, the Dycem flooring's been quantifiably superior at particle removal, be they non-viable particles or be those viable microorganisms.
Awesome. And then our last question comes from Matthew. Do you have a method or a recommendation for disinfecting hard-to-reach areas like ceilings and HVAC ducts of clean room where standard cleaning procedures are not feasible?
That's always a tricky one. I mean, the trouble is Annex 1 says that every clean room should be designed in such a way that all areas are accessible and cleanable, but that's not going to be easy with an aging facility. I mean, there are various kind of cleaning instruments and things that can be used, like extendable mops and sort of things. You can get round things which can be a possibility. Another thing to consider is the sort of periodic use of vapor. So purchasing like a standalone, say, vapor phase hydrogen peroxide generator, and periodically decontaminating the clean room in that way. And they're particularly useful for routinely looking at aseptic areas. And that one of the things when I spoke about the preventative maintenance, one thing I've shown that is, you know, if you're doing work, say in a grade B clean room, and engineers need to access panels, then after those activities, using things like VHP technology can really help bring the contamination levels down.
Awesome. Thank you so much, Dr. Sandle, for helping to answer these questions. I think we were all able to learn quite a lot from this webinar. There will be the slides available after the presentation. And of course, I would encourage you all to follow Dr. Sandle on LinkedIn and join his LinkedIn groups for microbiological research. He offers a lot of great information. I'd also encourage you to check out Dycem.com to learn more about antimicrobial contamination control maps and the benefits that they can bring to your facility. Thank you all so much for joining us today. Have a great day.